This lesson is on the inverse of a function. The inverse of a function, f of x, is denoted by f, the little exponent -1 of x. We say this like f inverse x. The function and its inverse have the property that if f of a equals b, then f inverse b is equal to a. In this first example, I'm going to be talking about how to determine the inverse of a function numerically. So the function that we're talking about right now is the quadratic function, f of x is equal to x squared. I just put in the table of values that you know, so these are the key points on your x squared graph that we've already talked about. The only reason that I did this one is because it's a very popular graph. You've talked about it in grade 10 a lot, and you should know it off by heart by now. Before we can start doing this, I am just going to create a new table. So on the left hand side it will be f of x, and on the right hand side it will be f inverse x. So what I'm going to do now is I'm just going to take the information on the first table and input it into the second. So in f of x we have a couple of coordinates, -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. When we're finding the inverse of a function, it is as simple as taking our x and y values in a coordinate and switching them. So -3, 9 will turn into 9, -3. -2, 4 will turn into 4, -2. And we will continue. 1, -1, 0, 0, 1, 1, 4, 2, 9, 3. Now, if I were to draw a graph of this, I'll just draw my axes in here. I have my original function. This is going to be a really rough sketch, by the way. Now, if I were to go ahead and plot my f inverse x, I would have the point 9, -3, 4, -2, 1, -1, 0, 0, 1, 1, 4, 2, and 9, 3. It may not be obvious right now, but after I tell you, you will start to see these patterns happening. When you're switching the x and the y coordinates, what we are doing is we are doing a reflection of this graph in this line right here of y equals x. So when we are doing this, if you were to graph them, you would see this obvious reflection. So if you folded the piece of paper along the blue line that I drew, and you put paint along the black graph, it would be the reflection, the red graph that you see there. So on this slide, you're just going to see a couple of things that you've already seen. So the table is the exact same table that was on the previous slide. I did just bring it over so that you could visually see again. The graph below is a nicer representation from Desmos of what I attempted to draw on the previous slide. This gives you the perfect visualization of the original graph, so the red one, the inverse graph, the blue one, and the green line is y equals x, which is exactly what it says at the top here. Switching the x and y coordinates reflects the graph of f of x in the line y is equal to x. So the reason that I did this is because I did want to talk to you about the domain and range of this function and of the inverse function. So if we're talking about, I'm just going to draw a line here, if we're talking about our original function, f of x, and we're talking about our domain, we can clearly see that eventually that red graph would have a domain of xer, and our range is, sorry, I don't know why I didn't do a squiggly bracket there. Our range is YER such that y is greater than or equal to 0. Now, if we're talking about our inverse function, so our blue function there, and we're looking at our domain is xer such that x is greater than or equal to 0. So if we're taking a look at our blue function, all of these x values are above 0, so they're all positive. And our range, so what kind of y values could we get? Well, eventually this blue graph will get forever up and forever down, so our range is just YER. Now what we're seeing if you take a look at these two is that the domain and the range have essentially just switched. If you are writing your own note, you can see at the bottom right hand side of the screen there, I just wrote it out for you. The domain of f of x is the range of f inverse x, and the range of f of x is the domain of f inverse x. Obviously, when we're dealing with domain, it's always x's and range is always y's. However, we're talking about what comes after the such that. That is what switches, not the actual letters themselves. You are going to be asked to determine the inverse of a function algebraically, so it doesn't always make sense to create a table of values, switch the coordinates, and redraw a graph. And it definitely wouldn't make sense to do that if you were attempting to find your own equation. So what I have for you are the 4 steps that you will follow if you're attempting to determine the range or the inverse of a function algebraically. Like I normally do when I'm giving you steps, I have wrote all 4 steps out for you. They are probably not going to make sense until we go through the equations, so please keep that in mind and just focus on the steps that we're going to do together in the next couple examples. So step number 1 says write the equation in y equals form. Replace f of x with y. So basically, no matter what the equation is, you need to make sure that everything is on the right hand side or the left hand side, and the only thing that's alone is f of x. The next step is to interchange the x and the y in the equation. The third step is to solve the new equation for y, and the fourth step is to replace y with f inverse x. Our first example is f of x is equal to 2x minus 3. So we're going to go through and we're going to follow the steps. So step number 1, write the equation in y equals form. This is in y equals form as soon as we do the last part of this. Replace f of x with y. So instead of f of x, I'm literally just going to write y equals and rewrite the rest of the equation. Step number 2, interchange the x and the y in the equation. So instead of a y here, I'm going to have an x. 2, and instead of an x here, I'm going to have a y. Step number 3, solve the new equation for y. So if I'm trying to isolate y, I need to do a couple of things. The first thing that I'm going to do is move this negative 3 over. So I will get x plus 3 is equal to 2y. The next thing that I need to do is divide both sides by 2. So my new equation will be y is equal to, that's a really ugly x there, sorry about that, x plus 3 divided by 2. The fourth and final step is to replace our y with f of x. So I need to write f inverse x is equal to x plus 3 divided by 2. This is my final answer. Our next example is f of x is equal to 2x squared plus 16x plus 29. Now right away we can see that this example is going to be more difficult. Because we have an x squared and an x, we can't just simply rearrange the equation and solve like we could in the previous example. So the first thing that we're going to do is step number 1. We are going to replace the f of x with a y. So we are going to get y equals 2x squared plus 16x plus 29. Now before we go any further, what we are going to do is rewrite this equation in vertex form. I'm going to tell you why after, but basically the reason that we're going to do this is so that we are only dealing with one x in the entire equation. So I'm going to walk you through the steps of rewriting this in vertex form. So we are going to factor a, or 2, out of the first 2 terms. X squared plus 8x plus 29. Now we're going to take our new b, so this 8x, and we're going to divide it by 2, which is 4, and square it, which is 16. That number is what we're going to be adding and subtracting to this bracket. The next thing that we need to do is remove this fourth term from the bracket and factor the remaining 3 terms. So y is equal to 2, x plus 4. Remember, we can take this b and divide it by 2. When I take this negative 16 outside of this bracket, I do need to multiply it by the 2 out front. So this is going to become a minus 32 plus 29. The final step is to simplify this, so x plus 4 squared minus 3. Now you can see that I am only dealing with one x. Even though it's squared, we can deal with that. Now we physically only have one x in the equation, and we can move on to step number 2, which says that we need to switch our x's and our y's. So at this time, we are going to be getting x is equal to 2, y plus 4 squared minus 3. I did just want to mention that if you switched your x's and y's in this first step and then you completed the square, you would get the exact same result. I just didn't want to confuse you because typically when we complete the square, we are doing it with x's. The variables don't matter, so you can do it at any point that you choose. Now that we've switched the x's and y's, we are going to be solving this equation. So the first thing that we need to do is move this negative 3 to the other side of the equation. So we are going to get x plus 3 is equal to 2y plus 4 squared. The next thing that we're going to be doing is dividing both sides by 2. So x plus 3 is equal to y plus 4 squared. The next thing that we're going to be doing is taking the square root of both sides. This will get rid of the squared that we're looking to get rid of in the right-hand side over here. So what we'll be left with is the square root of x plus 3 divided by 2 is equal to y plus 4. Finally, we need to take this plus 4 and move that over to the other side of the equation. So I'm going to be getting, sorry, I forgot to tell you that when we are taking this square root, we do need to be adding a plus minus here. We are going to be getting plus or minus the square root of x plus 3 divided by 2, subtract 4. It is very important that your subtract 4 stays out of the square root sign. We've done it after we've taken the square root, so we need to make sure it is outside. And that is equal to y. Our last step is to replace the y with f inverse x. So f inverse x is equal to plus or minus the square root of x plus 3 divided by 2, subtract 4. Now for those of you that are wondering, I did just want to go back and talk about this point right here where I told you to include a plus minus in front of the square root. When we are squaring something, we know that negative 4 squared is positive 16 and 4 squared is positive 16. So since we could have negative numbers or positive numbers that are being squared equaling the same value, we don't know which result it will be, so we do need to include this plus minus every single time we are taking a square root of something.